Hi guys. Today we want to quickly look at sorts. What are sorts? Sorts are simply irrational numbers. And so what are irrational numbers? Irrational numbers are numbers that cannot be expressed as ratios of integers. Say A divided by B, you know, A divided by B, where A and B are integers and B is not equal to 0. As long as we cannot express the terms, the numbers this way, they are simply called sorts. Okay. Now, examples of sorts are we have the square root of 2, we have the square root of 3, we have the square root of 5, we have pi, we have what else again? Let's say maybe the square root of 11. A lot of them. Okay, there are so many of them, so many numbers that are irrational. Okay, so irrational numbers which are roots, square roots of rational numbers, basically. Okay, they are all referred to as what we call surds. Okay, so quickly we're going to look at the rules that are governing surds. Now, the first one we're going to look at is what we call the addition law. The addition law. Now, for the addition law, let's say we have root 3 plus root 3. Okay, this gives us 2 root 3. Okay, that is what the addition law is saying. It gives us 2 root 3. And it does not give us, like some would say, it does not give us root 6. No. This is simply 2 root 3. So root 3 plus root 3 does not give us root 6. Please take note of that. What this simply means is that there's a 1 or an invincible 1 out here. So that is what you're summing up to give you 2. Therefore, if I have, let's say, 3 root 4, okay, no, let me use root 5. If I have 3 root 5 plus 2 root 5, it's simply going to give me what? 5 root 5. So this is very simple to understand. Please take note of that. And also take note of the fact that we are summing up these numbers outside there simply because they have the same square roots. Okay, because they have the same sorts. So please take note of that. Then quickly we're going to go to the subtraction law. The subtraction law is very similar to this, to the addition law. Subtraction law is saying that if we have 3 root 2 minus, okay, minus 2 root 2, as long as they've got the same sorts, okay, we simply subtract the numbers outside. So that gives us root 2. Of course, 1 root 2, but we don't necessarily have to write the 1. So let me take another example. Let's say we have 4 root 5 minus 2 root 5. Okay, no, minus 2 root 2. Now, what is this going to give us? I know some people would say this is going to give us 2 root 3. That is 4 minus 2 is 2. Root 5 minus root 2 is root 3. But it is not true. That is not correct. Okay, so you need to take note of this law. We must have the same sorts and then subtract the numbers outside, and that's all. Okay, so quickly we're going to look at the multiplication law. Multiplication law. Okay, so for the multiplication law, let's say we have root 3 times root 2. That simply gives us what? Root 6. Root 3 times root 2 give us root 6. Okay, so in this case, you don't necessarily have to have the same sorts. Okay, different sorts can simply multiply each other. Okay, Also, please take note that when you have similar sorts, the product of two similar sorts simply give us the number without a square root. For example, root 3 times root 3 is going to give me root 9. And of course, 9 is a perfect square. So the square root of 9 is what? 3. Okay. So we've ended up what? Rationalizing this number when it multiplies itself. Okay. So that is that. Now let's quickly look at the division law. So the division law, a little bit similar to the multiplication law, of course. Let's say we have 144 divided by 9. Okay. Let's say we have this. Now, this is still the same as picking them one after the other. Root 144 divided by root 9. Okay, so and what's root 144? That's 12. And what's root 9? That's 3. So 12 divided by 3 is 4. So these are the laws that governs whatever we do in search. Okay, so just looking at them, you need to familiarize yourself with them. Now let's go straight into solving a few problems on search to help us get these concepts going deep. All right, so we have a problem before us. It says simplify the following. So we have the square root of 80. We want to simplify that. So let's start with that. The a, we have root 80. Now, what am I going to do? I want to simplify that. Now, look at this. You see that root 80 can be broken down into root 40 times root 2. Yeah, because 40 times 2 gives me what? 80. Then I can still break down 40 further into, excuse me, I can break 40 further into root 20 times 2. So what do I have now? 20 times 2 times 2. Okay. Now, even 20 can be broken further into root 10 times 2. Then I have this 2 here. 2 times 2. Okay. And root 10, I can break root 10 further also to 5 times 2 times 2 times 2 times 2. Okay. Now, at the end of the day, what do I have? I'll notice something. All of these now can simply be written down as root root 5 times root 2 times root 2 times root 2 times root 2. Now, of course, if you remember previously, I told you that once you have similar sorts multiplying each other, okay, they simply become the rational part of that number. So root 2 times root 2 is simply going to give me what? 2. Now, root 2 times root 2 again is simply going to give me 2. So that becomes 2 times 2, 4. So this is root 5 times 4. And this is simply going to give me 4 root 5. Now, I decided to take this approach to make you get to understand it better. Okay, we could have gone straight into saying root 88. The square root of 80 is simply 16 times 5. Just it's simply root 16 times 5, and root 16 is 4. Okay, which gives us this. Then the 5 remains as a surd. Okay, so but I just wanted to break it down for you to see. All right, now we're going to quickly go to the next one. So we have the B part is 45. So for in this case, what are the two terms that we can break 45 into? So we have root 9 times root 5. And of course, you remember that your 9 is a perfect square, right? So the square root of 9 is what? 3. So this is 3 root 5. Very simple. Now let's go to the third one. We have the square root of 162. What can we break 162 into? Excuse me. 162 can be broken into 81 times 2. Now the square 81 is actually a perfect square too. So 81 times 2. So this simply gives me, the square root of 81 is what? 9. So this gives me 9 root 2. Okay. Yeah, this gives me 9 root 2. Then the final one is, we have the square root of 98. And 98, that can be broken into 49 times 2. 49, like you know, is also a perfect square. So that's going to give me, the square root of 49 is 7. So this is going to give me 7 root 2. So that's it. That's how you simplify surds. Okay. Very, very simple. Now let's look at the second question we have. The question says express the following as single surds. So this is like doing the reverse of what we just finished working on. Okay, so we have to express the following as single surds. The first one we have there, A, is 5 root 3. Now, this is simple. If you recall from what we've been doing, you see that if we have root 49, we end up taking off, looking for the square root of 49, and that gives us 7. So we use it. Now, this is like me going back to this kind of numbers or expressions. So the square root of this is 5 root 3. This is simply going to mean I take the 5 back into a square root and I'm going to get 25. So that is root 25 times root 3. Now, what is root 25 times root 3 going to give me? So 25 times 3. When I multiply them, what am I going to get? 3 times 5 is 15. 3 times 2 is 6, 7. So this is simply telling us that the single surd we have there is root 75. So just very simple. Just trying to show you how to play with surds. Now, we also have this, express this as a single surd. You know, 4, when taken into the square root, will give us 16. So it's going to be 16 times this. Okay, so this at the end of the day gives us the square root of 32. So that's the single surd we have there. Then we also have the C part. It says 2 root 5. So I need to take 2 into the square root and it gives me 4. So that's 4 times 5. So this becomes root 20. Then the D part is 3 root 7. So when I take the 3 into the bracket, it gives me, into the square root, it gives me 9. So at the end of the day, what I have is root 63. So that is just basically what surds is all about. So in the next video, we're going to talk about things like conjugates of surds and rationalizing surds. So I'll see you in the next video. Thanks for watching.